Welcome to part 2 of the Geometry Prep for Fluid Flow Simulation tutorial. In part 2, we're going to extract the fluid volume. But before we do that, I want to show you how to view the geometry in cross-section mode. So click on this face and simply hit X. This puts you in cross-section mode. You can also click this icon up here to enter cross-section mode. To change the location of the cross-section, click here to enable the move grid, and then simply grab one of these arrows to translate the cross-section to any location that you desire. You can also double-click on the curved arrow to snap the cross-section by 90 degrees, or drag the curved arrow to change the angle of the cross-section to any location that you want. To get rid of that move grid, simply click here again. Now to exit cross-section mode, you can hit D on your keyboard. Now let me show you how to place a cross-section along an axis. So hover over this face and you'll see the axis for that face is shown. Put your cursor on top of that axis, hold Control and scroll forward until the axis is highlighted. You can see at the bottom, it indicates the axis is highlighted. Left click to select the axis and then hit X to go into cross-section mode. And you'll see that we are in cross-section mode and that cross-section has been placed precisely on that axis, which is very helpful in many cases. Let's hit D to go back into 3D mode. Now the last technique I want to show you is to place a cross-section at the same location that you had it previously. To do that, simply hit X to go into cross-section mode and just click in free space anywhere. And you'll see that the cross-section goes back to where you had it last. Okay, so very easy way to go into cross-section mode. Now, while we're in cross-section mode, you can see that we have that filter element in pink. Before we extract the fluid volume, we want to hide that filter element. So just click here on the tree and you can see the filter element is hidden. Now go back into 3D mode by hitting D on your keyboard. Okay, the volume extract tool is located in the Prepare tab here. Click here to launch the volume extract tool. Okay, now what we're going to do is select the inlet and outlet faces. So this is the inlet face. Go ahead and select that. And this is the outlet face. Okay. The next thing we're going to do is click here to select a seed face. It can be any internal face. So let's click this one right here. Okay. Now click here to preview inside faces. What this does is it shows you in a red color all the internal faces. But right away you can see that there's something wrong. Even the external surfaces have been colored red. So this is an indication that there is some sort of leakage in the geometry. But how do you figure out where that leakage is? It's very simple. Grab this blue dot and move it to the left to replay the selection of those internal faces, starting with the seed face. So you can see right at the beginning, we have a leakage. And I believe the leakage is right here. So if I change the view and I replay it, you'll see right here. Let's hit escape 2 times to dismiss the volume extract tool. And you can see that there's a hole at the bottom of the outlet section. Maybe it's a location for an air pressure sensor or something like that. So we need to get rid of that hole in order to extract the flow volume properly. How do we get rid of that hole? Well, it's quite simple. Let's go back to the Design tab, select that hole, and simply click Fill. And that hole is gone. Okay. Fill is a very powerful tool to eliminate these kind of geometry features that you don't care about. Now, there's another feature that I don't care about, which is this loop of a fillet or a round. Double click to select that loop, the round loop. You can see that there. Okay, and then hit fill again. Okay, quite easy. And there are many applications for the fill. And I'm going to show you some of these in the next video in the series. Okay, so now let's go back to the volume extract tool in the Prepare tab. Click here to launch the volume extract tool. Click there on the inlet. This is the outlet. Let's select a seed face and let's preview the inside faces. Okay, now that looks much better. Only the internal faces are colored red. So click the green check mark to actually create the fluid flow volume. And let's hit escape 2 times to dismiss the volume extract tool. I'm going to go back to the design tab. Now you'll notice on the geometry tree or model tree right here, we have a new component called volume. And if you expand that, you'll see the fluid volume. And I've selected that to highlight the fluid volume. Okay, so it's that easy. That's how you extract the fluid flow volume. Now let's take a look at the actual volume. It's quite easy to do that. You can select that volume, right click and say hide others. Okay, and here's what that fluid flow volume looks like. Now let me draw your attention to a specific feature that I actually don't want to include in the fluid flow volume. So it's this feature right here. I'm going to select it. Okay, and it's perhaps caused by something in the solid geometry, and it's really not desirable for simulation. So I want to find out what's causing this feature and how do I get rid of it. There are many different ways to get rid of it, but I want to show you one specific technique which highlights the functionalities in Ansys Discovery. Okay, so right click and show all. Okay, and let's go back into that previous cross section by hitting X and clicking in free space. If I zoom back in here, you'll see exactly why we have that strange feature. There is a small gap right here in the solid geometry, which is causing the fluid flow volume to contain an extra feature that we really don't want. So how do we close this gap? Well, first let's hide the fluid volume by clicking here. Okay, and let me show you, 3 different ways to close this gap. The first one, if you're in cross-section mode, you can simply grab this edge and pull or drag to close that gap. It's that simple. Click here to undo that operation. The second way is to invoke the pull tool. So I can click pull, select this face, and now that I have the pull tool invoked, you'll see I have many more options. For example, I can hit the space bar and I can enter a value such as 5, which is 5 millimeters, and you can see I can move that to a precise location. Or if I click here to hit undo again, I can select the up to option in the tool guide, and I can select this face and have it pull exactly to that location. Let's click undo again. Okay, and let's hit escape 2 times to dismiss the HUD. So you can see that was closing the gap using the pull tool. And you can also do the same thing with the move tool. So for example, I can click move, I can click this face, and then I can move this up to this location, easy. I can click undo again. Let's zoom out a little bit. Let's triple click to select that entire body, and now I can grab this green move handle and I can move that entire body in. Okay, now let's hit escape 2 times and let's zoom in again, and you'll notice that that gap is closed. So really, many different techniques to close things like that gap, and different techniques work better in different applications. I just want to show you all the different techniques that we have. Now we've closed the gap. How do we update the fluid volume? Do you have to recreate it from scratch? Actually, you don't. In the tree, right-click on the fluid volume and say update volume as created. Okay. What it's going to do is it's going to recreate the volume with all your previous inputs, but taking into consideration the geometry change you've made on the solid. So now if I click here to show the fluid volume, okay, you'll notice that it looks really good. in this location. Okay, so let's hit D to go back into 3D mode. Click here, right click to hide others. Okay, and if I go into this view, you'll see that in this location, everything looks good. Okay. Okay, now let's take a look at some other places where the geometry is not perfect. Okay. If I zoom in here, you'll notice I have these weird features, kind of these sharp edges. They are also an artifact of something on the geometry or the solid geometry, which is causing the fluid domain to have this weird or strange feature that I don't want. Now, I can do the same operations that I did just a couple of minutes ago to get rid of it, but I think it's actually easier to just directly manipulate the fluid volume. Okay. Now, to do that, let's go into this view. You can simply box select. Let's rotate it to make sure you have all the features and click the fill tool. Or you can hit F on your keyboard, which does the same thing. F is the shortcut for fill. Okay. Now, you might be wondering, what if you cannot visually see these small features and sharp angles? Is there any way for you to identify, small features like this? And there is. If you go to the Prepare tab, and sharp edges is one example. Okay. Make sure you have both concave and convex selected. You can use the default edge angle. Simply select this body. Okay. What this tells you is all the locations where you have a sharp angle. Now you can inspect this manually. So for example, this sharp angle is not much of a problem, but this sharp angle up here is a problem. So the sharp angle tool just allows you to visually quickly figure out where you might have potential bad geometry. Okay. Now dismiss the sharp edges or sharp angle tool by hitting escape 2 times. And then let's just get rid of that. Okay, so we can box select like we did before and hit F to fill. Okay. The last thing I want to do is get rid of all these small rounds. These rounds are not important for the flow behavior, but it might result in a very big mesh. So how do we get rid of that? Okay. Click on a face, click on that round face, and then go down here, and you'll notice that we have the Power Select tool. The Power Select tool is great because it allows you to select a bunch of geometry based on the characteristic of that particular geometry. So in this case, choose the all rounds equal to 0.5 millimeter option. You can collapse here, and you'll notice it has selected 785 faces. So it's all the rounds that you see highlighted over here. So just imagine if you had to manually select 785 faces, it would take you a long time. The Power Select tool just does it super fast. So you can simply hit F to get rid of those as well. Because you have so many faces, it might take a few seconds longer to get rid of those. If I zoom back in, you'll see all those rounds are gone. Not just in the original location, but all these other locations as well where you had those rounds. Okay, let's go back to the Design tab, and let's right-click and Show All. Okay, so here we are. So that concludes part 2 of this tutorial. Please go to part 3, where I'm going to show you how to slice up the fluid volume so that you can assign different properties to different regions, like a porous media for the filter and so on. Thank you very much, and we'll see you in part 3.